So, guys, in real time, majority of the times, the compression technique would be compression technology that we will be using along with the tool is a EDT. EDT is the embedded deterministic test, which is owned by Mentor Graphics, which means Tessent. So Tessent is one of the tool given by the Mentor Graphics. Okay. So for your understanding, let me make it very clear here. So Simons has acquired. Okay, Simons has acquired Mentor Graphics, and for DFT, they provide DFT tools like Fast Scan, DFTMax. Yeah, DFTMax is used for both EDT and ATPG. Normally, Tessent shell is what we use, which is the basic shell. Okay, within Tessent shell, only fast scan and tetramax will be invoked. So if you invoke Tessent shell, automatically the other tools will come. But I think tetramax you can directly invoke using the name of tetramax. Okay, so shell, basically all the tools will have shell. For Synopsys, we have DC shell. Okay, DC shell. Likewise, for Tessent, we'll have a Tessent shell. So fast scan is for purely for scan insertion. Tetramax is for EDT and ATPG. Now what happens is in real time. In real time, the model will be in real time. What happens is for scan insertion we use DC, Synopsys DC, that we have the tool. Currently we have it. Okay, we'll be working. We'll be working on this labs also. And for compression, okay. Again, for Synthesis also we have to tell. Synthesis also scan Synopsys DC only. Okay. Next, compression. We use EDT in real time, which we don't have actually. It is a trend which generic, like 40% of the market will use this. I mean, I would say 40, 50, 50 to 50. Okay, 50% of the market will use EDT compression technique with the combination of scan insertion with the Synopsys. So tools will be used vice versa, like different vendors will use different vendors, not single vendor. Okay, based on the efficiency of that particular domain. EDT is very much comfortable for many of the market people. So semiconductor companies, market means semiconductor companies. So semiconductor people are very much comfortable with EDT. So they will use EDT compression, or they are adapted to that flow and they don't want to change the flow, because at times, right, few companies don't waste time in trial and error method to convert into Synopsys compression techniques. Okay, so 50% of the semiconductor companies will use this kind of flow: scan insertion, synthesis, Synopsys DC, then again compression, EDT. Again they have to use synthesis tool, because compression synthesis is not done by Tessent. Okay. Anybody joined? Anybody want to join? Okay. Okay. Synthesis again synapse DC. Which we have. After this, once compression is done, we'll go with ATPG. ATPG again 50-50. Few will go with what DFT-Max. Sorry, this is a DFT-Max is a synopsis tool name. Both names are little bit same. Test compress. Test compress is a SN test compress. This is for internet. Okay. And ATPG DFT-Max and test compress. Both are used. Not at the same time, depending on their flow comfortability. Both have equal weightage. I mean, in the market, few are comfortable with DFT-Max flow, few are comfortable with test compress percent flow. So the problem here is with the flows. Certain companies from ages they are comfortable with certain tool, they got adapted to that. So the entire team is comfortable with that particular flow. So suddenly what happens is they want to migrate into a different tool, okay, for a different project. Again, some duration or at least 1 month of time is required for them to transition from one tool usage to the another tool flow. And the problem is not with the transition. The problem is they develop certain scripts. Okay, every company, every service-based company or manufacturing company, any company in semiconductor, they develop their own custom scripts on top of existing tool commands. Okay, tool commands will not change. Tool commands are same. Few people will make it automation. They use automation scripts like Perl and Python. Okay, using Perl and Python, mostly Python and Tickle. Okay, these two scripting they use it and automate it to a certain level that push button, so that any engineer who comes, he want to do scan insertion, he can just there will be few inputs that he has to do, and rest if he just click on that button, everything will be done by the tool. I mean the flow. So it's a push button system. Okay, this current era that we have, all the major companies started doing this push button system because uh, many projects are coming in line. So when you have more projects or ease of ease of working to reduce any manual mistakes, companies got adapted to this automation. So when they do automation, they have done for only one certain flow, which is like scan full synopsis tools only, end to end of DFT flow, or full test flow only, or a mixed flow of synopsis and test. So if suddenly they want to change from one flow to another flow, again they need to spend a lot of time, the flow engineer. Okay, so this is very important thing to understand. Let me break it down for you guys. So many times, right, due to the IP security, okay, and confidentiality, even they do not reveal any information to the engineers also. Engineer will get to know what is required, what is not. So let's say, let me take a company called Intel. Okay, Intel. Let's not take company name. Let's say some XYZ company. Okay, XYZ company has its own SharePoint cloud server where every data information is stored. Okay, are you guys able to follow?
Yes, sir.
Okay, listen carefully. This is how flows and companies work while execution flow work. Okay, SharePoint is something in website. There will be a website for the SharePoint network. Okay, where you can store information, data, exchange data. Okay. So all will be there in that SharePoint. And people use OneNote also, Microsoft OneNote, to maintain meeting records and all. Okay. So what happens is, because of various domains within DFT and throughout what we call the ASIC VLSI flow, what we have is different domains, right? Different working domains, like RTL design engineer to till physical design engineer and tape out. We have multiple stages of execution process, design process. So different domains have to work collectively. Okay. So always they do not use mail only. For example, if RTL design engineer has done he's finished his RTL coding, he has to deliver to the next stages, physical design or verification or a DFT. Now he can send through mail, but you want to make a confidentiality or IP security of that. Okay, instead of mail and ease of access and to have in one place. So means if you have the communication within mails, there will be multiple mails coming into that person, that particular engineer's inbox from various activities of companies or many things. So this categorization and going through and sorting out these mails is very difficult in real time execution. So for ease of working, what they do is create one repository. Okay, so they will create a SharePoint repository. Okay, so different companies will have different view. Okay, again I'm telling that also. So different, but this is the way. Okay, this is the basic way how companies manage. Now different domains has to co-work on the same information of that particular project. So think for one project, starting with the artificial design and physical design on post silicon debug and diagnosis system, totally we will have around 250 engineers or so. Okay, on a larger SOC design I'm talking. Okay, when you have that many engineers have to work on the same project, they have to maintain synchronicity across the versions, release of versions. Okay, version releases. Okay, they have to maintain a version releases, and everybody has to maintain. Okay, RTL design has released version 2 released today, so DFT has to pick the same. So this synchronicity, if you in order to maintain that synchronicity, you have to pick the same version too. Okay, so if somebody sends you mail, RTL design engineer has sent you mail for DFT to start working on DFT. These are the collaterals. Okay, these are the inputs. You can start now. Okay, so few members are not tagged in the mail, are not communicated properly. Okay, then there will be a miscommunication. To avoid any miscommunications, so we keep a common repository where this RTL team will publish the information there. So we will pick that information, DFT or PD, anybody who needs to execute the next stage, they will pick from that area. Okay. So when you have that kind of environment, and in the work execution, in order to ease a little bit more, this is I'm talking about cloud repository. Now what happened is, in recent days, I mean recent years, we started to have a Unix based servers to store all the project information. Okay, so Unix based servers, let's say, Okay. So in this area, FE collaterals. Okay. Net list of that particular partition or a block. Okay. Will be stored here. Let's say block MMU top is a partition name. MMU top. Inside that, you will have MMU top underscore MMU top dot VZ. Sorry, dot V dot GZ compressed formula. So this is a Linux representation. We'll teach you that little bit. Don't worry. Not little bit. We'll give you complete learning on that. So this is a disk. That means this is a server. Okay, in the Linux server. Okay, we will have certain space. So this disk is the memory of this disk is 2 TB. Okay, 2 TB memory allocated for this particular disk. For which project? Project 1. Inside project, this is front-end collaterals. Front-end collaterals means RTL design collaterals. RTL people has given this. They have written the code and they have delivered you RTL. Likewise, physical design will have it. Like a physical design collaterals, DFT collaterals. DFT after execution of DFT will have created a directory called DFT collaterals. So this kind of scenario we use in real time. So what happens is this is a repository who has the project access. Let's say that now we are 4 people. I am working in one project. Okay, each one of you is working in a different project. So only those who are working in that project will have separate user access. So we will create separate user access only for him. So others cannot enter into this project area. So this kind of confidentiality, IP security will be there in the major companies. Okay, so this is the way how we preserve data, secure data. So data, any company that you join, the first initial company trainings would be on the data security, okay, and how to behave in the work culture. All these trainings will be there. This is common. Okay, so this is how in real time we work, even in DFT, not just DFT, in the semiconductor I'm telling. Okay, so when you have this kind of system, okay, you will have customized flow also to clone or produce the project data to your work area. Okay, now let's say the same example. NHF disk 1, okay, project 1. I'm working in project 1. Now I have to create a directory. This is the work directory of the particular project. I have to create. Okay, now I'll create my work directory. Okay, in that work directory, there are certain commands to create directories. Okay, we will learn that later. Linux commands, through Linux commands, how we create directories and all, we will learn later. So in the lab section, we will learn. Okay, now in here, I will start working. Okay, I'll create one more directory called DFT. In DFT, I have to work on one block, that is MMU top. In this, I will create one more directory, mbest. Okay, parallelly, I will have one more directory. Okay, as a scan. Parallelly, ATPG. Likewise, I will create directories and do my product execution there. Okay, so now there are flows, customized flows. Okay, there are certain commands for population, clone, produce, or populate. Okay, populate the project data or collaterals pure work area. So this is my work area. Okay. There are flows which there will be a single command. Okay, single command. If I just execute that command in the Linux terminal, automatically this FE collaterals, okay, any other collaterals required for DFT will be coming and sitting into this my work area. Okay, that means they will be copied in my area. Okay, now after executing that command, I will get all this FA collaterals required for my execution. Okay, and along with that, I will have tool setup also. So I have to work on tools, right? Now I also need tools. Tool setup. Tool setup directory will be created in which all the tool access related information will be there. So when you execute, when you try to invoke any of these particular tools, it will be invoked with a proper licensed information. Okay. This till this part, everything is understood.
Yes, sir.
It should be clear, right? I mean, any queries you are able to understand, right? Everything that I have told. Any query, any confusion in between? I can repeat if any confusion if you have any confusion.
Clear.
It's clear. Okay, good. Okay, so this is how real-time working will happen. Now, when you have this kind of environment, okay, tools are invoked automatically. Tools are automatically invoked. Okay. Now, this is one total semiconductor flow or the project execution flow. Along with this, okay, additionally, one more automation will be added. Okay. Additional automation is something that one more automation is DFT or a PD or RTL or a design verification execution flows. Okay, flows are scripts. So as I said, using Python, Pickle, Perl, shell scripting, okay, using these four, they will develop the flow. So flow will be in such a way that, okay, just give me inputs. Okay, what is block name? Okay, block name. Engineer's work will be, okay, block name is MMU top. What else you need? Netlist path. You give the path from here. Okay. NFH, disk 1, project 1, NGK, equalitals. Okay. MMU top dot v dot gz. Okay. Next, what else you want to give? So if it is a not fully automated, few more inputs you might need to provide. Okay, regarding what you are doing. Okay, you want to only run or a debug, okay, or all these settings will be there. So you just have to provide it in the flow, and you have to just use dot slash run dot csh, whatever the run file, execute. Okay, so this kind of uh, environment will be there in real time. Okay, now why I am telling you all of this is because in this customized automated flows, okay, tools we whatever the tools that we use, they might have customized it. So if you want to change the tool to your different tool, again they have to automate this entire flow. They have to again change this automation to a respective tool. So tools are okay, but employees has to understand. Employees has to again what we call migrate or transition to that tool behavior and commands, because commands are different from tool to tool, vendor to vendor. DFT is very customizable. That DFT, okay, let's say they want to change the flow. Okay, DFT can survive because DFT is very much comfortable and easy upgradable. Okay, whereas physical design team, if they want to change the flow, it will take nearly 3 to 6 months for them to understand the flow to a different flow. Recently, that is what happening. Okay, recently the physical design team, the flow has been changed because a new tool has been created by the Synopsys. Okay, previously the same tool of ICC2, okay, Synopsys ICC2 we used to use for physical design. Now they moved to Fusion compiler. Okay, now within that migration only, people are not able to take it. The physical design team. Okay, it is taking a lot of time for them, but still even then, because of the advanced features in the Fusion compiler, companies is asking, or the particular hierarchy managers are asking, please try to take training, spend more time, and learn that, and try to what we call adapt it to that and execute it. For DFT, there is no such thing. All these tools are the same tools which we are using since the beginning. Okay, and you should know both the tools. Okay, at least for compression technique. Okay, you should